Hello and welcome to one of many in NHP's suite of webinars. My name is Tharindu, an application support engineer for NHP Electrical Engineering Products. In this session, we will be discussing the software named Revit and the topic of building information modeling. Please note that this webinar will be a high-level overview to generate awareness for what Revit and building information modeling is, but in saying that, we will dive into some points of detail to better understand both. We will start with the obvious topic of understanding what the software Autodesk Revit is and its relationship with building information modeling. We will cover what Revit files are, or as it is better known in the Revit environment, a family or model. We will also go through how Revit and these said families differ from other software environments and file formats, including IFC. We will explain how Revit families are categorized into various levels of development. We will discuss the current use of Revit here in Australia and New Zealand, as well as compare to how Revit and building information modeling are applied globally. Without further ado, let's get started. To understand what Revit is and its use case, it is integral that we understand building information modeling, or BIM for short. But before we can get to that, let's take a step back and understand BIM's placement in the progression of communicating information. Because naturally, as time has moved forward, how we present and visualize information, may it be for an enclosure or an entire building, has changed significantly over a short period of time. We have moved from hand-drawn blueprints and drafting practice to 2D computer-aided design, which then transitioned into its three-dimensional format. And now, arguably, to building information modeling, facilitated by software such as Revit. Each progression has absorbed the previous methodology but provided improvements in efficiency, communication of design intent, and overall visualization. Imagine the time taken to manually draft the design of a panel board. It would have been an extremely lengthy task. If you developed the same panel board in 2D CAD or 3D CAD, you would see a reduction in the required time from manual drafting all the way to 3D modeling, especially when you factor in the likelihood of design changes occurring along the way. Now suppose if you can embed information into that panel board, information such as material, color, density, weight, manufacturer, where it can be used, how it can be used, website links, all of this in a single file, a single source of truth, if you will. BIM history dates back to the 70s and 80s, with strong links to establishment of various CAD software. On the surface, BIM appears to be the development of three-dimensional digital design or models, like you often already see. But in truth, it is very much more than that. BIM in its essence is a model-based collaboration process which allows for cooperation between multiple disciplines, such as architecture, engineering, and construction, when tasked with the development and management of a built asset. A built asset can be a building, a bridge, or any other form of infrastructure. BIM's core strengths are communication and information. It is the ability for all members of a project to easily extract and view information at any point in an asset's lifecycle. The 3D model, or models, are merely the shell which encapsulates it. Revit is simply a software environment which facilitates building information modeling and the ability to extract different forms of embedded information from said one source of truth. Whether it is supply chain needing to know what amount of raw materials that they need to order, to manufacturing team needing layout or mechanical drawings, contractors requiring a construction schedule, even end users who perhaps want to find the installation manual Revit and BIM has the ability for you to view such information. Fun fact, the One World Trade Center in Manhattan is one of the earliest major projects to use Revit as its primary design platform. Now, with this newfound understanding of BIM and Revit, let's touch on the difference between Revit and various other software environments and file formats you may have heard of. I will not be mentioning every single modeling software, otherwise we will be here all day. Some that you may have heard of would have been PTC Creo or Pro Engineer, SolidWorks, BricsCAD, AutoCAD, Microsoft Paint. Just kidding on the last one. Each of these have their own native file formats, but there are also universal file formats which are used. The most common being the step file or STP file for 3D environments and the proprietary DWG file for 2D. These universal files can be imported and opened by most, if not all, 3D or 2D CAD modeling software, respectively. Revit has two of its own native file formats. The first being a RVT file. This is the file in which you develop the overall asset, for instance, your building. Think of this as the overall project file. The second file format is the RFA file, or family as they are called. These are models which are created independently to the previously mentioned RVT project file, but are then usually imported into the project's file itself. An example scenario being the RFA file of a light fixture, where you would create, then import this RFA file into the RVT project file of a building and place them in each of the rooms which you would require lighting. Furthermore, with Revit families themselves, you can import and embed complementary file formats within them, such as photometric lighting files, allowing you to visualize, render, and analyze data within Revit itself. Touching on the ability of analysis, another one of Revit's major advantages is the level of integration. There are multiple analysis and design tools, such as Elim tools for lighting analysis and PowerCAD for electrical design. You can import and export some foreign CAD files for the software environments we mentioned earlier into Revit. Exporting a Revit family to, say, a 3D file, for example, is indeed possible, but at the expense of any embedded information within the family. It would no longer be a BIM object. The term BIM object being a more generic term without needing to refer to a proprietary file format such as RFA or RVT file. Importing a 2D or 3D file into Revit is a straightforward task. But whilst you can import other 3D files into Revit, it is usually avoided unless explicitly necessary. Most Revit users opting to create the model within Revit itself rather than importing. I will touch on why a little later. Like there are multiple software packages for 2D and 3D modeling, there are also numerous forms of BIM software available, Revit just being one of the more popular. With so many different BIM design and viewing software available to use, how would you share files between any of them, you may ask? Good question. IFC to the rescue. Based off the step file used in 3D modeling, the IFC file extension, developed by the organization Building Smart, is used as a universal file format to view, coordinate, and share models between various BIM-enabled software. With all this talk of BIM file formats, this is as good a time as any to touch on the level of development, also known as LOD. LOD can be described as a means of defining the extent to which model elements have been developed, from conception in the mind of the designer through to their construction and operation. The acronym LOD is used for both level of development and level of detail, both terms relevant in BIM. While similar in concepts, level of detail can be considered the level of graphical or geometric detail in a model, where level of development describes the overall state of a BIM object. Specifying LOD provides a method of clearly articulating how reliable a BIM object is. In other words, how much information and how accurate is the information within the BIM object in comparison to its real-life counterpart. Consider level of detail a subset of level of development. In Australia, BIM level of development is categorized as follows: LOD 100, 200, 300, 400, and 500. The table on screen describing the difference between each. There is also an intermediate value LOD 350, which we will not go into detail about, but naturally would fit between LOD 300 and 400. Like BIM itself, LOD is also a communication tool. It can be used as a method to maintain a level of consistency between BIM objects, or it can be employed as a reference to which team members can measure to. BIM objects can also be developed at a different pace to one another, or at different periods in a project's timeline. The last thing you need is a breakdown in communication where you have one team develop a BIM object like this, another team developing like this, while at this point in the design phase, the project manager was expecting this. The level of development selected depends on the intent of the Revit project being created. If you are creating a Revit project to simply communicate the location of certain products inside a building, LOD 200 to 300 BIM objects may be sufficient. Which leads me back to my previous comment about importing 3D files. Imported 3D files can on occasion contain too much graphical and geometric detail of an object. This can affect the processing speed of Revit depending on how powerful a computer you may be running. If you do not require such detail, all you are doing is wasting computational power trying to maintain such level of detail. On a large building where you may have 2000 GPOs, 300 lighting fixtures, 500 tables, all detailed to as-built levels of development, you could have made a matchstick model of your building by the time you wait for your project file to actually open. Building information modeling has been around for quite some time, but only in the past 5 years or so has it gained its current traction. Even then, there is still a divide in uptake across the globe. In Australia and New Zealand, building information modeling and Revit are considered to be in the early adopters phase, only just starting to transition into a more early majority adoption. Right now in Australia and New Zealand, Revit is still compared and used with the likes of any other CAD software and are not 100% committed to virtual design like they are in the US and the UK, where asset and facility management via BIM is becoming more commonplace. Government involvement has pushed the uptake of BIM usage, the UK in particular, specifically mandating a certain level of BIM reporting for all government construction projects. Some companies are even utilizing BIM as a method of risk management and as a construction support tool. Where high risk, heavy stakeholder investment is involved, companies are implementing virtual reality technology, like you see in the video, to do walkthroughs of BIM projects. The goal being to provide high impact visual interpretations of a final project design before physical construction is approved. Individuals are able to see every aspect of the digital design as if they were standing within the building itself. In other cases, like in the video here, Augmented reality via a Microsoft HoloLens is used, where stakeholders are able to overlay the virtual model on top of a site in development to confirm that certain components have been installed in the correct locations, as well as determine how much space is remaining in a room when equipment is eventually installed. All of this made possible via BIM. Lastly, before we wrap things up, there is an abundance of information about Revit and BIM available. I have noted some down on the screen for those who would like to dig deeper into this wonderful world. For those who would prefer to get hands-on, you can download a trial version of Revit from Autodesk's website. Upon installation, you will find both a full program on a 30-day trial and a Revit viewer. The Revit viewer has reduced features to that of the full version, one being the inability to save. The plus side being the viewer can be used indefinitely, as opposed to the trial version with its 30-day expiry. Nonetheless, the viewer is more than sufficient for those who want to learn more about the Revit environment. That's all for this webinar. I hope you have found it beneficial and gained a fundamental understanding of the topic discussed. To quickly recap, we discussed building information modeling, a model-based collaboration process, and its relationship to Revit, a software platform which allows the facilitation of BIM using 2D design, 3D design, and embedded information. We discussed level of development and its importance as a communication tool, and the advantages of using it as a reference during a project's design and development. And finally, we discussed how BIM is currently used around the world and the relevant standards which govern its implementation. Thank you all for tuning in until the end. Well done, you've made it. 10 points to Gryffindor. If you would like to find more webinars from NHP, please go to nhp.com.au or our dedicated NHP YouTube channel. If you have any questions relating to this webinar or about Revit in general, please feel free to contact me. Thank you again and enjoy the rest of your day.